Okay. All right. So if anybody has a question at any time, let it rip. All right. So I think you're all aware where everything is, but just in case. Okay. All right. So forgot about that. Anybody has a question? It buffers and then yeah. Sorry. So if you need to ask a question or go out and do something, remember you're going to have this on YouTube later if you need to watch it later, okay? And we'll try to take a break about a little over halfway through because I think we're here till about 1, all right? And the class, if you looked at the schedule on online, it says Wednesday's class is really complicated with lab. Basically, just think of it as a 2-hour lecture. All right, there's my personal website. You've got all the links in Canvas. So if you need any links at any time, you can go to Canvas. So why should we possibly care about sig figs? All right, so it's pretty much the most boring topic. You probably know a little bit already. Hopefully this will be easy for you. It's a good like starter day, but maybe we should think about why you might care about this. So I was trying to imagine a system where you had like a robotic arm or something, right? And then maybe there's a lever here and some kind of device here, some kind of claw. Now, if you think about this, when you build this thing, right, there's probably going to be some hinges, some bolts, maybe some bearings and things, and everything involved in that, when you fabricate it, there's a tiny bit of error in designing it. You can't guarantee something is perfect. And so one of the things, sig figs is a cheap, easy, fast way of approximating the errors when you start adding in lots of pieces. Now, here we're talking about a machine. In our homework, we're going to be talking about numbers, right? So if we have lots of different numbers that we add or multiply together, each one of those numbers has some error in it, right? Maybe one was measured with a ruler. Maybe one was measured with a stopwatch. Those little errors can add up. And the idea is, if we keep track of sig figs, we know approximately how good our final answers are, and we know approximately how much those little errors have added up to affect the final result. Got it? That's why you should care. Let's move on. If you're a mechanical engineer, later on, you might talk about tolerances. And some of the math that you do in tolerances is sort of like an advanced version of sig figs, a better way to do it. So it's not bad to have some exposure. We mainly use this in lab. It's going to be on test 1. So let's get it done. All right. Now, if at any time I'm boring you, work ahead in the book. One of the things that I did, right? Does everybody have the book already? If you don't, you can go to robjorset.com, and I think the first chapter is online. Those of you sitting in the back, if you want to use those computers, I'm trying to get some laptops in here. Usually they're here, but today they got taken away. But yeah, so what I did is I just printed out the homework for the semester. I got this off Canvas. You can just start doing problems if I'm boring you. You know what I'm saying? So if you already know what I'm talking about, get to work, grind through the homework. And then if there's ever something that you really need to do, I'll be like, hey, everybody, you should really listen. Even if, yeah, I'll give you a cue if you need to listen up. All right. So on page 1, you can see these sig fig rules. Rule 1, 2, 3, 4. So if I have this number, thanks, Angus. How many sig figs does this number have? 4. This has 4. Now here's the deal. If I had written it like this, it's really unclear. Technically, we would say this has 3 sig figs, or 1 sig fig. So this has 3. Jeez, saying too much at once. This has 4 sig figs. This has 1 sig fig. The idea here is one of these rules in here, it might be rule 3 or rule 4. Rule 4 is the tricky one. This is called a trailing 0. Okay? It's trailing because it's to the right of all the other numbers. Now, in this case, this is a trailing 0 right of decimal point. Okay, if you have a trailing zero to the right of the decimal point, it suddenly becomes significant. Once this one is significant, everything in between is also significant. Is everybody okay with that? Now here, these are trailing zeros, but notice they are all left of decimal point. If the trailing zeros are to the left of the decimal point, not significant figure. Yes.
I have a question.
Yep.
Is there any circumstance in which the 100 may have three significant figures, even if
Yes.
it doesn't have a decimal?
Yes. And what we do is a trick in chemistry class, or every once in a while, something in chemistry is useful. All right. So by the way, as a physicist, I love to make jokes about chemistry. You'll point out I love to brag that we beat chemistry in the contest there. But I actually love chemistry too. All right, anyways, so in chemistry, this is one of the things that I really like that. If you want, and this is in my book too, right? If you put an underline here, that's a trick for telling people, hey, this is significant. So that's how I'm going to do it. And if you look in the book, look at page, give me a sec. Oops. I got a problem here, I swear, somewhere. Where'd it go? Did I pass right by it? No. I got one I'm looking for. Page 6. Look at page 6. If you look at page 6 in the workbook, and again, if you don't have a workbook, just bring it up on the computer there. Go to robjorstad.com, go to Physics 161, find the workbook page, and you can have the questions up there. And I don't mind if you want to use the big screens at the back. All right, so, but do you see all those underlines there in that problem that you asked about? That's how I'm going to keep track of the sig figs, right? And notice there's a column for done correctly and done incorrectly. You'll see something where I use that underline to show you specifically where the sig fig it is. That way I don't have to be rounding all the time. I just round at the very end.
Okay.
Did that address your question?
Yes. Yes.
That's how you could show how a zero is significant, and we're going to use that all the time.
Okay. Yeah, I finally get it. The one problem that I normally had in my previous classes was that I didn't understand what significant figures were until that makes sense.
Yeah. So
basically, when 100 is an approximation, you know what's an exact value.
Well, so what this is saying is this 100 is good. So, right, when I say 100 and I don't say anything, I'm implying plus or minus up to 50.
Yeah.
If I say 100 and I underline right here, that's plus or minus 5 because I'm off in the tens column. If I say 100 here, then it's plus or minus 1. So what it's saying is, I could say there's 100 students out on the quad, but I wasn't sure. I didn't count very well. It's 100 plus or minus 50.
Okay.
Or maybe I actually took some time and did better counting. So maybe I'm off by 5. Or here, I counted every single one. Maybe somebody left, so I might be off by about 1. You see the difference?
Yeah, I see that.
It's specifying the quality of the number. The more sig figs you have, the higher quality the number, so to speak, right?
Right.
So if you're taking measurements in a lab and you get 4 sig figs on a number and you measured it well, you're like, okay, this was not the problem in my experiment. It's something else I did, right?
Right.
Because I know I got this one right. Now, what if you held the ruler wrong? That's a different problem, but yeah, good.
Yeah.
Generally speaking, we want to shoot for 3 sig figs if we can. And after the first test, I'm probably just going to tell you, hey, everything, just assume it's got 3. But up until the first test, we're going to try and keep track of sig figs to get you in that habit. Got it? So if you hate this, 6 weeks from now, you won't care anymore. Well, since we're on page 6, look at that. Look at the very top. So there were rules for talking about how many sig figs you have, but in the book on page 6, there are also rules describing how you keep track of sig figs and how you multiply and divide them. All right. And so maybe what I'll do, I know I'm kind of jumping ahead. I have no idea how far all of you know this. So we can slow down later if we need to, but let me just remind myself what I got to do here. Let me see, is it 6? Okay. So in this case, so I want to kind of show you the final result here. And then again, if I'm going too fast, we could talk later. But let's say we had three numbers, right? I'm just going to make up a problem like three. Actually, let's use one from the book. On page 7, 1.8. A. Thanks, Angus. So problem 1.8a, it says 120.0 divided by 3 plus 70 equals 1. Now, obviously, you could punch this into your calculator and get it no problem, right? Piece of cake. But what I want to do is try and use the sig fig rules. In particular, let's identify these numbers. How many sig figs does 120 have?
4.
4 sig figs, just like the last one, right? How about 3?
1.
Exactly. How about 70?
1.
1. Okay, so now what I want to do is I want to use the rules at the top of page 6 to go through and do this operation. So first, we're going to do 120 divided by 3. Okay, it's 40, but how many sig figs? Should I write 40.0? What do I do here? How many sig figs here? We got 4 in the top, 1 in the bottom. Which is the crappier number?
1.
The 1 sig fig, right? That's limiting us. We only know this to 1 sig fig. You can think of that as knowing, yeah, okay. So when we do this one, I'm going to deliberately underline the 40 there, right? So 120 divided by 3 should only have 1 sig fig. Now remind me, 70 had 1 sig fig, so I'm just going to underline it. And this is what I mean by that underline. We can use that to keep track. So now we've got an addition. What's the answer? 110. How many sig figs? 2. When you're adding, we have to keep the column, right? So I like to do addition. And I know this seems cheesy, but look, if I'm off in the tens column here, and I'm off in the tens column here, when I add them together, shouldn't I still be off in the tens column? And that's the point of sig figs. Got it? Just gives us an idea of what we should be doing with these numbers. And so this is kind of a crazy calculation. Yeah, none of them had 2, and you end up with 2. So I'm not trying to lie to you. Something on test 1 is going to be some tricky sig fig question to see if you bothered to do the practice and got this right. Okay? Everybody cool with that?
So when it's division or multiplication, the sig fig always becomes a smaller number?
Yeah, so multiplication and division keep the crappier number of sig figs. Addition or subtraction keep the crappier column.
Okay.
Got it? So this is the crappiest column. The tens column is crappy, right? I know that I could be off in the tens column here, right? So that's how I think of it. Multiplying, dividing, keep the number of sig figs. Addition, subtraction, keep the column. And if you, is that good or not?
Well, I understand the multiplication division, but for subtraction and addition, I'm kind of
okay. Let's say I had 6,238 chickens, and I take away 6,327 chickens. I know this to 4 sig figs. I know this to 4 sig. How many chickens you got left?
1.
How many sig figs?
1.
You're off in the ones column. You see what I'm saying? Or if you have $1.03, right, and you take away 97 cents, right? It doesn't make sense to say you still have 3 sig figs. In fact, how many sig figs do you have here?
3.
1. Leading, these are called leading zeros. Leading zeros, never significant. So we've seen all the tricks with sig figs. This is a very, very brief reminder, but I just want to emphasize leading zeros, never significant. Trailing zeros, like we saw in the first example, sometimes significant. I know I've been going kind of fast here. Just stick your hand out, thumbs up, thumbs down. Is this kind of an okay review or not? Like, I'm assuming most of you have seen some of this before. Okay, okay. All right, so, yes, go
I
ahead.
have another question. Under what circumstances would the zeros in front of the number, in the case of decimal, be significant?
Never.
Never? Okay.
Trailing is the one you have to be confused about. So let's go back and make sure we got this. So there's two sets of rules here you need to memorize. The ones at the top of page 6 for doing the math, okay? And then the ones that were on page 1, rule 1, 2, 3, 4. So if we go through those rules real quick, basically anything that's not zero, significant. Anything between significant is significant. Leading zeros, never significant. So I'm looking at page 1, the first 3 rules.
Yeah.
It's the fourth one where all the trickiness comes in. So of course it's going to be the fourth one that's on your test, and I'll try to trick you. So basically all the sig fig questions on your test are going to have lots of zeros peppered all over. So you have to keep track what's a leading zero, what's a trailing zero. And remember, leading, not significant. Trailing depends on the decimal point. Is that good?
Yeah.
Okay. And then the math with sig figs. Remember, when you're multiply and divide, the number of sig figs. When you're doing addition, subtraction, the column. Okay, and that's kind of the core on that. Feeling good on sig figs for now? Okay. How about notation? So let's look at page 2 and 3. Just open up your book and lay it flat. I'm going to erase the board. Read a little bit about those notations. Look at the example. We're talking about scientific notation and engineering. Hey, Jules, when you get a chance, if you want to maybe send that to the people on Zoom, could you do that? Appreciate it, Jules. And it's not going to distract me if you have a hard time reading it, you need to come up, you know. Just erasing the board, people on Zoom. And maybe I'll check in here with the Zoomers here. Any questions, you can throw them in the chat direct, and I'll try and check every once in a while, or like I said, Jules will give me a heads up if there's something I need to check. Are you seeing things okay? Contrast or anybody from Zoom?
Everything looks fine.
It's okay. Okay, good enough, right? Okay. All right. So I want to talk about scientific notation and engineering notation next. Now, there's going to be times where I actually ask you to write in one of these forms, and we'll take off a point on your test if you don't do it right. So before we spend all day on this, I'm going to show you the secret, okay? For this class, you have to have a scientific calculator on test day, right? And tests are always in person only. So the trick is these calculators have a mode button on them, right? And so I don't know if they can see this on Zoom. Let me just try and zoom in a bit here. All right, they can't see very well, but the idea is if you're messing around somewhere up on one of these calculators, usually there's a mode button. And if you don't know this, I know what to do. All right, it's always a little different with the first time I've taught in this room with the Zoom and Room technology, so I'll get better at it. I'm just a little bit off here. So what I'm going to do, I think this will work, so that I could just show you this, and you can actually see it. There we go. So what I'll do, I think I could change the Zoom camera here to this button and try it. Give me a second, sorry. Probably want 6. Let me just adjust it a little. Sorry for the delay. Whoops. Ah. All right. I know it's not perfect. But now, you can probably see this calculator. All right. So if you've got a calculator, hopefully one of these two is pretty good. I highly recommend that one. This one, which one is this? The 30? These two are both good. Just get the 36. All right. It's really good. Or talk to Mesa and see if they can get you a number. All right. So if you have some number in here like 0.00023, whatever, right? And you want to get this in scientific notation, I hit the mode button. I go down here, and so your calculator is probably going to look a little bit different, but it's got these buttons on it. So the sooner you get a scientific calculator and start practicing with this, you'll be good. So I can hit the engineering mode, quit, and it does it for me, right? Then you don't screw up counting it on your test. If I want to go to scientific mode, I could just do this, and I could hit second answer and just hit it again. And so notice you get different ways of writing this if you're in scientific or engineering notation. In scientific, this number, well, all right. Maybe what I'll do is I'll just write this on here. All right, we started out with this number. What was it? I've forgotten the number I wrote. All right, there it was 0. All right, how many sig figs is that? 5, right? Leading zeros, never significant. So then I get my calculator in here. Is this showing up on Zoom at all, people? Can you see it at all?
Yes.
Yes.
Looks like it is. So when we get to scientific, right? Now, obviously, we could do this a different way that might be slightly faster. But when I do it this way, whoops, I'm just going back to the mode. Now I'm hitting an engineering mode, right? I'll get this back on the board in just a second. All right. All right. Get that in focus. Come on, focus. All right, it's a little out of focus. I apologize. It's not focusing right now. All right, but the idea here is on a test, what would I do if I were you? And I said, write this in engineering notation. I'd get the number in my calculator and change the mode. Is that going to work for you, or does that make sense? Now, here's the deal. Engineers like this because then everything is in a power of 3. They use only powers of 3, so they wouldn't use centimeters. Centimeters is 10 to the negative 2 meters. They would use millimeters, kilometers, meters, things like that. And so it's handy when you're an engineer to always use engineering notation, because everybody's writing things the same way. You're less likely to make stupid mistakes. That's all it is. It's not like the best way or the only way. It's just the standard way. And if you always have your exponents being powers of 3, 6, 9, you have fewer prefixes to memorize. It's just a little bit less work in that sense. All right, so questions on that? That's the recommended way to learn how to do your engineering notation. Let's take a second. You can also use the examples and count over. Maybe I'll do this, but what I'd like you to do is take a minute, try some of the problems randomly on page 2 or 3, right? Just try a couple of them. Jules, if you want to circle the room, you could do that, or if you're getting Zoom hits, whatever you want to do, all right? Let me get this off here. Just try a couple problems so you're not listening to me yak all day. All right. I'll get the lights. Good. Okay. any questions from Zoomers as well. So I'm just having people work on, you know what I'll do while you're on Zoom? I'll get you some links. And by the way, I forget, some of you haven't had me in class. Are you aware that there's all the solutions to this workbook are online too? So if you didn't know that, you could just go to robjorson.com, or if you got it, I tried to put a QR code on here. I didn't know how big to make them, but that should take you right to the solutions. So if you want, you can go, oh, whoops, that's my blue one, purple one, whatever. So if you're waiting to hear back and get feedback, the whole point of having the solutions is you can do a problem and check it, do a problem and check it. Bring it up on your phone. Normally we'll have laptops in here, but it's a little bit weird today. All right. Okay, cool. So I highly recommend having the solutions open so you can check before you get too far ahead. So again, you're totally fine having your phone out, working on it. This first chapter, you don't really need your own separate notebook, but maybe by chapter 2, you might want to get a notebook because the problems are going to get too big. So far, so good. Okay. Cruising along. All right. All right. Check. So you got the problems on your phone, or how you got to look there. So here's the solution. That way you can just look at what you want. All right, how about here? Doing okay? We'll get the solutions up. Yeah, cool. All right. Should I just let you work? Oh, is this old edition? Yeah, old school. Well, it's probably still pretty good. Yeah. If there's, I'll show you on the solution stuff real quick. If you go there to the, go to 161 workbook, one of those links. You scroll up. If I ever do a problem that you don't see here, like say, oh, 1.9 and a half, probably right there. What I'm saying. So that's the way I think you can still use this, but occasionally you're gonna have to go there to hear me reference a problem that I see. But it might be one or two that maybe change. So just be vocal about it. If you see something there, like, oh, and we'll figure it out. I fixed a few more typos and stuff like that. All right, you doing all right? Okay, okay. So far, so good.
Yes, sir. Thank you.
Good, good. Rolling. No questions yet? Okay, got it, got it. Okay, making progress? All right, all right. Were any of them tricky or were they all pretty?
This one is confusing.
There's some weird ones, right?
I'm like actually thinking about this
Yeah, it's just fun.
one. Right?
Yeah, so you could write times 10 to the 0,
Yeah.
and then generally, if you have to write times 10 to the 0, you don't write that. But if you had written on a test 12 or 12 times 10 to the 0, I would have given you credit.
I see. I was just very much overthinking on
Well, that's why I put it in here. That way, if it accidentally showed up on a test by accident, you're not having to worry about it. Got it? Yeah, and then you got the solutions to check it, right?
Yeah.
Okay, okay. Okay. Yeah, all right. And then remember, if you get done and you're waiting for the class to go, you get to start working on the next problem on the list. You know what I'm saying?
Yeah.
Okay, and so what do you think? Does it make sense or no?
Yes,
Or-
it makes sense.
Okay, cool. What do you think? So far, so good?
I think so. I just not sure what to check.
Oh, okay, go to robdorset.com
Okay.
and then look for the workbook.
Right here.
Yeah, that's it. Sorry. I'm not a graphic design. I don't know how to like make sure my website shows up good on phones. It's just like so cheap. Whatever, it's got the file, but it's not slow.
Would you be willing to let somebody like work with your website to make it mobile acceptable just as a side project?
Maybe,
Okay.
maybe. Like, I'd have to think about it. Right now, I'm like, oh man, I don't want to do anything, right? Because it's like I'm already doing way too much because of like, I'm having to learn stuff all the time.
Okay.
But that would be good, right? I write my webpage in Microsoft Publisher. Nobody does that, right?
Yeah.
So, yeah, I should do that, and it's on my list of things to do, but it's really low because the links work. So, yeah, all right. So now, if you look here, there's the solution for chapter 1, 2, 3, etc.
Oh, okay.
Got it. Yeah. So it's like old school technology, but whatever. Yeah, you're right. I should totally do that.
I got a question.
Yeah.
So instead of putting times to the 10, can we just put like E2?
I don't want you to get in the habit of writing, like E is acceptable if you're using Microsoft Excel or like Python or some computing language, but I don't want you to get in the habit of handwriting E notation because that's potentially very confusing. So yeah, I'd say that's a bad habit to write it that way. It's totally good to put it in code that way.
Okay.
Does that make sense?
Yeah.
So yeah, so there was a good question just raised. And I'll check in with the Zoomers here. Jules, are you getting any activity on any questions from anybody on Zoom? Okay, so remember Zoom, you can send a chat to myself or Jules and we'll just keep looping the room and then checking you guys. The first week is a little bit crazy. I try to let people work at their own pace because we all have a very different level of familiarity with these topics. But eventually, like probably in about 2 or 3 weeks, we'll start to come together and it won't be so awkward. Oh, this is bad. So there was a question raised. Maybe I'll just mention this. I would write this as 1.23 times 10 to the 2. I would not write it as 1.23 E2. So if you're using Excel or code or something, right, this would be totally fine on a computer program, but when you're handwriting it, don't write with the E notation for handwritten work. Yeah, that's all I'm going to say about that. I think it could lead to confusion. Pretty unlikely to lead to confusion, but it's still possible. All right, so get this board cleaned up a little bit. All right, I figure that's enough time to at least give you a chance to look at this stuff. Oh, I need to bring that up. All right. Okay, and so, yes, question, any question? Yes.
How many significant figures are allowed in scientific notation?
Infinite.
Okay, so
Infinite many are allowed. Yes. But now, how many are actually used? It depends on the measurement.
so let's say you have a number that is very, very long. It's just a lot of bunch of numbers.
One of the longest numbers is actually the mass of the electron. If you look in a physics book, well, we got one here, don't we? We got it in here.
Like 6.9.
Well, I'm trying to get all the sig figs, right? Do they list? Oh, they don't give it all. But yeah, like, I forget what it is, but something goes out and there's something like 9 sig figs on the mass of the electron. It's one of the most precisely known quantities in the universe, right? So this might be the mass of an electron. Mass of an electron. So you could have 9 sig figs. You could have 10. It's whatever the number dictates. The number of sig figs is not determined by the notation. The number of sig figs is determined by how you measure something or how it was recorded or how well you know it. The notation should never affect the number of sig figs. When you change notations to engineering or scientific, you should never change the number of sig figs. For example, 1200. How many sig figs?
2.
2 sig fig, right? What is this number in engineering notation?
120.0.
Engineering
Oh, not never mind. It's just
over
120.
3. How many zeros should I write?
1.
None.
Wait.
This has 2 sig figs. This also has 2 sig figs, right? Is that green showing up on Zoom?
Yes.
Yeah.
All right, maybe not. Okay, all right, thanks, Jules. I'll try to avoid it though, it's a little weak. So the idea here is, right, let's start with the number 1200, right? These are trailing zeros, but they're all to the left of the decimal point, not significant, not significant. If this number has 2 sig figs, when you go to this notation, you should also have 2 sig figs. 1, 2, done. Is that helping?
Yes, I just thought that you would need to include three
No.
numbers, so it's like that.
No, because this now accurately represents, if I had a 0 here, what if I had written 1.200? How many sig figs does this number show? These are to the right of the decimal, they're now significant.
Okay.
That would be lying to the people of the world. And we don't want to do that. Yeah, so you see what I'm saying?
Yeah.
This is where you get into trouble with these subtle little things. If you take 1200 and change it over and accidentally include the zeros, suddenly that means, oh, you'd have to know this number to 4 sig figs. If you send that to the machine shop, they're going to bill you twice as much. You just wasted money. So accurately displaying the, I don't know, I'm thinking out loud here, but if you accidentally overrepresent the number of sig figs required for a number and you send it to somebody to do work, they're going to read that number and say, whoa, I need to get 4 sig figs. I need to use the best equipment, the most expensive process. And so, yeah, you want to be careful to not overrepresent sig figs. It has problems. Is that good enough?
Yeah, but in the case of engineering notation,
Uh-huh.
right? Oh, okay.
This also happens to be scientific notation, right?
Yeah, that's what I.
The trick with engineering notation is the only powers allowed are 3, 6, 9, -3, -6, -9, etc. Okay,
Oh, okay.
so yeah,
There's it has nothing to do with the actual whole number at the beginning. Well, not the whole number, just the number at the beginning of the before the times 10 to the
right.
6, 9.
When you're doing engineering, you just pick a number and go over in batches of 3s, right? So, right, you go over 1, 2, 3. I can't go over another 1, 2, 3, so I stop there. This would be 12 times 10 to the third, right?
Okay, that makes.
Wait, shouldn't I write 0.0? No, because that would overrepresent the sig figs. Good.
Okay, that makes more sense.
All right, good.
Got a question.
Yep.
So for the mass of the electron, was that found using like an
Quantum field theory.
Or, oh, so.
Yeah, we can talk about that later. Yeah. Actually, see that picture over there, that poster with that diagram with the weird Feynman diagram on it? You do a bunch of those, you do a bunch of math, you get the mass of the electron at 9 sig figs. Something like that.
Oh,
Well, yeah. But
so it
that's,
stops after
each one of those pictures represents integral calculations that are very annoying. So you do hundreds and hundreds of pictures. Yeah, so let's move on. Is that good?
Yeah,
We can talk about more later.
sure.
All right, so let's see where we're at now. Had a kind of a brief review there. Go to page 4 real quick. Go to page 4. We're going to look at a bunch of a data table here on page 4 in your workbook. And so maybe I'll just do a very small subset of this if I can get on a new screen here. All right. Imagine you have some numbers that look like this. So I literally just cut and pasted some numbers out of Excel. You always hear your teachers talking about prefixes, right? I know it's boring. But when you look at it, sometimes like this just looks ugly. This looks ugly. If you're trying to show somebody else and communicate with them in an easy way, sometimes prefixes make your work look prettier. And so we want to learn how to use not only both scientific notation and engineering notation, but also to then replace this ugly E plus O3 by the prefix kilo or K, right? Or if you had a bunch of numbers that had a bunch of leading zeros. Imagine if you had a graph where everything was done in microseconds. Oh gosh, now I got to think. Let's see. All right. What if you had a data table where your times were recorded every microsecond? Oh, you can just see how fatiguing it is to write this, right? So let's say this was your time in seconds. Wouldn't this look a lot better if I wrote it as time in microseconds? So it's 0, 1, 2, etc. This is all this is about, looking good. Because if you look good when you write your work and do a presentation, people pay more attention to what you're saying than how ugly your work looks. It helps you get a job someday if you make things look pretty. So that's what we're trying to do here. What we're going to do is then take engineering notation and add in the prefix. So try this right now. Before we go on, try page 5. If you need some examples, there's some examples at the bottom of page 4. There's your prefixes. And before anybody asks, look at the back of this book. Look at the back if you got it. That's the equation sheet you're getting on test day. Look, there's some prefixes in there. You see that? So if you're wondering, do I have to memorize that crap? Look on the back of the book, and that'll tell you approximately what your equation sheet will look like. I might add something or take something away, but I would try to let you know before I do that, okay? So all semester long, if you forget your prefixes, there they are. All right, let's try it again. Look at the examples at the bottom of page 4. Try a problem 1.6 and see how it goes, all right? Or any questions before we do that? Okay. And then Zoomers, how are you doing there? You staying awake? Is this painful?
good.
Moderately?
No, it's good.
Okay. All right, I'll do a spin around too. Maybe I'll just start right here. How are you doing?
No, just I'm looking at it.
It's always bad when I come to the first person who has to show up, they're like, oh, I haven't had a chance to start yet. I'll check over here. How we doing, Angus? Oh, sweet. Okay. I'm not sure we'll be able to do the Zoom camera to see this.
Yeah, I thought of that too.
I wonder if do you think we might be able to pull these two tables together and lift this up, or do you think it's too much water in there?
We could slide it onto a disc.
Okay, so maybe I'll call you in for that.
Yeah.
I might do that after the break. What's the break? I think pretty soon. That?
We should be getting a whole bunch of new laptops soon.
If anybody wants a laptop so you don't have to work on your phone screen all the time, or if you just want an extra screen, just get it. And then every day when you come in, if I forget, you can tell me. What's that? Oh, yeah, you're right. It's because those meetings never. You got it. You got it. Yeah, you got it now. You got it. Okay. Gotcha. Right back here. Okay. So far, so good. You want to bring your laptop, or you have it? Okay, I can have another one open so you can have it for the solutions. I'll bring it. I got it. I'll open it up. You keep working this way. Bigger, more screens, it's less time scrolling. All right, Jules, take yours over there. You want to take another loop around when you get time, that's cool. Are you able to add stuff to the Canvas site? Okay. I added you on the structure. But I don't know if it works. If you are, then we can have you write up whatever contact you want there. You know what I'm saying? If you've got nothing. Yeah. So Mike.
Oh, it's in my lab. I'm preparing for the next one later today. I'm like, what the hell is my laptop for?
Oh, did I take it? Oh, shit.
I told Randy.
Oh, thanks, man. Thanks. Here's the solution. You guys, do you want to share this one? Just so you don't have to always do that small screen. Yeah. If you get done with that, you can always try the problems right below too, where it's kind of, that's starting to look more like a test question, the one right below that big table. assume that would be 1.7. All right, it's kind of a weird day. We'll get a flow, like I said, in a couple of weeks. Get you one as well, just so you have it. Oh, actually, you got the solution on your phone. You're good. Yo, what's up? What's EQ? Oh, Becquerel. If you are curious, I believe I wrote up what all of these units are in the solution. Because like I thought doing this is so freaking boring. You gotta have something weird, right? At least now you learned what a Becquerel is or a candela.
You need
a
radio.
Yeah, you know what the bell is? You probably know what a decibel is, right? Deci is an archaic prefix, it's a 10 to the 1, right? So it's yeah, exactly. So it's like a tenth of a bell or whatever. Yeah, anyway, so, but nobody uses bells. Everybody uses dB, decibel, whatever. All right, anyway, that's hopefully that's kind of fun. All right, all right. Check it out. Anybody else need a laptop, or maybe you just want one? Got one, every party fired up. You're good? You guys need one or not?
I got mine with me.
Okay, okay. Good. Okay, okay. I think we're good. All right, sorry about that. There you go. See you guys too. Questions? Yeah.
So when I'm looking at the units, there are units for 10 to the -2, but there's no units for 10 to the -1. 10 to the -1 would just be like going over one.
I think that might be Deci.
Yes.
DECI, I think I didn't write that one, I didn't include it.
So,
Like decibels.
so then, so that would be the one also for like 10 times 10 to the 2.
I don't think there is one times 10 to the 2.
And 10 to the 1.
Oh,
that
times
would-
10 to the 2?
Yeah.
Times 10 to the 2 is DECA.
Oh, Deca? Oh, there you go. So there's one. But I guess this is what I'm saying about engineering, right? Who gives a shit as long as we just do all threes, right? So that's kind of the standard. Because then
Oh, I
there's
see.
fewer of these stupid ones you gotta remember.
Yeah, that makes
Yeah,
sense.
yeah, yeah. All right. Good?
Yeah.
Okay. Yeah. And you definitely could learn, like, if you want to look up a full list of these, including the old kind of outdated ones, you could look at that too. So, yeah, I mean, it's kind of interesting to see the stories. But yeah.
I mentioned that the newer ones are the ones that are either smaller numbers or bigger numbers.
Well,
Either it's
basically just try to always think in threes, right? And then in this class, the exception is sometimes we use centimeters just because it's convenient. But really, we should be using millimeters in here. Yeah. Let me check with the Zoom people here. All right, how you doing out there in Zoom land? It's like the most boring lecture ever, right? Hopefully you're just doing something on your own. Oh, go ahead, Liliana. What were you gonna say?
Oh, nothing. I was gonna say that we're all good here.
I can't hear you.
Oh,
You can put it in the chat if you want, Liliana. Yeah, so as I'm just going through, let me. Okay, good, good. Are you guys able to find some problems and get to work on something there? Hopefully. That's what everybody in class is doing too. And like I said, it's not always going to be this much circling the room, okay? It's a weird couple of weird beginning here. All right, all right. Don't be shy if you do have something to say. All right. All right. So maybe let's regroup for a minute. All right. We're kind of all over the place, and this would probably be a good time. Obviously, if you're excited and you want to keep working on it, that's fine. I'm not offended. But this is kind of how the class is going to go, where I try and give you an example, then ask you to do a problem. And what will happen is gradually we'll have bigger and harder problems, and there'll be more discussion. But at the beginning, there's not a huge amount of discussion. It's just check the answer. So apologies if this feels a little weird right now. The problems on page 7 in the workbook. If you're looking at page 7 in the workbook and you're wondering, like, what's this guy going to do to me on test day, right? That's usually what students care about. I have asked questions very similar to the questions on page 7 and just see who can do this stuff. And what page 7 is you've got sig fig rules, you've got prefixes, and then you've got to deal with actually doing algebra with the numbers and keeping track. We've already talked a little bit about page 6, but again, if you look at page 6, there's that done correctly, done incorrectly. The biggest thing students do is they round too early. So I'll try to give you an example here. One of the things we want to avoid is called intermediate rounding. And if you know all this, again, just keep working. You want to hear about it, you can listen. All right. So let's say we have, oh, let me pick a problem so I don't screw it up. Maybe I'll just use this example, right? So I'm working on the example on page 6. I'm on the right screen. Yeah. Okay. And if I work this out live, maybe it'll be more interesting. Maybe it'll be less interesting. I don't know. All right. So in this case, every single number in here has 2 sig figs. Agreed? And what you don't want to do is do the first step and then round everything to 2 sig figs. Then do the next step and round everything to 2 sig figs and just keep rounding each time. What you want to do is work through all the math without doing any rounding, and then round at the last step according to sig fig rules. And so there's always some question on test 1 where I deliberately make it tricky so that you have to actually pay attention and follow the rules and track the sig figs. So in this case, oops, let me get back there. It's handy to use this one because then we don't have to keep punching numbers into the calculator. But so what I would do is when I punch this number into the calculator, I get 1.58, etc. You might say, how many extra digits do I need to write down? Well, you got to keep at least 1 extra and mark that the sig fig, this is really a 2 sig fig number, right? But I keep an extra digit so I don't round. So the idea is if you rounded this to 1.6 and this to 1.1, you'd be introducing a small error. And if you do enough steps, you're adding in more and more errors and things get out of control. So let's do this next one. Hey, everybody, this is Dom. Do you know Dom?
Yes, sir.
There you go. He's the man. All right. He's here to keep me in line. Ha, good luck, Dom. Impossible. All right. So in this case, we started out with all 2 sig fig numbers. So what I like to do, and actually what Dom hates seeing in his tests, is to see this little underline. So we'll show you how you can make both me happy and Dom happy later in just a second. So now I'm going to do this step in my calculator and keep track of it. And fortunately, I have it written down here, just so I'm not boring the crap out of you. Whoops. How many sig figs should this number have? Take a look at it carefully. We're doing 1.58 minus 1.13. I know you're tired. You want your break. Pay attention right now. How many sig figs should this one have? Why do you say 2? Just go ahead. It's okay. Just what's your logic?
Because of the 1 in front of the decimal.
Ah,
If you do a column and then you subtract it, you can see it.
we're doing columns, right? So this is what happens. You think it's 2, but right when you write it out like this, you could see what I called the crappy column earlier. This is in the tenths column. This is in the tenths column. At the end, we should actually only have 1, and it should be right there. All right. Now, I think this is still. All right. So now when I square this one, sorry I'm using this example so heavy here, but it speeds it up. All right. So when you square that one, think about it. When you square this number, when you multiply 2 numbers, what do? Do you keep the column or the number of sig figs? So 1, I only get 1. And remember, this is a leading 0. It's not significant, right? Is everybody okay following the sig figs to here? All right. And remember, on Zoom, you could shout out a question anytime you want. So now, what do you think we're going to get when we do this? How many sig figs are we going to be left with? Why? The column. It's not 1 because it's 1 versus 2. It's tenths column versus hundredths column. You see what I'm saying? So I would probably rewrite this one, but since you said it, we got it here. We got it written out there. Right? This one's off in the hundredths column. This one's off in the tenths. I keep the crappier of those 2 columns, the most leftward. All right. And then finally, now that this problem is done, even though all the numbers started out with 2 sig figs, we're going to end up rounding to 1 sig fig. So the way you could write this correctly on the test and not irritate your engineering instructor would be to leave off this mark and just finally round it. Dom, would you say that's what you prefer?
Yes.
Is there anything you want to say about sig figs, Dom, while I've got you here? That, I mean, it's boring, but necessary, right? It adds up over time if you don't actually get it done, right? I feel like you're going to be wasting time in other classes if you don't just get this done now, because eventually you're going to have to do this.
Don't round until the end.
Yep.
Don't unround.
Yep.
Some weird reason where you have 1 sig fig or 2 sig figs, and all of a sudden you need 3. You can't just add a couple of zeros.
All right. What do you think? So far, so good on this? This is the biggest thing that students will screw up. And like I said, it's going to be on test 1. I'm going to try to trick you. I'm warning you right now. So be ready for it.
Oh, we do round like in the extra, like where we divided the first numbers in the parentheses. We round it to.
Yeah. Well, do you agree these have 2?
Yeah.
And 2? So when you do this, this is 2 sig figs, this is 2 sig figs. And I did division, right? Should I keep the column or should I keep the number of sig figs?
The number.
Yes, so that's why I kept 2 here. Now, if we really want to get crazy, a lot of times, engineers, anytime the first digit is a 1, they'll stick an extra digit on. I don't want to explain too much about that, but you'll notice this in the workbook over time. Engineers oftentimes will add a sig fig to digits that start with 1. If you want to talk about that with me later or in office hours, we could discuss that. Definitely we'll discuss it in lab, so don't worry, it'll come back. All right, we got to take a break. Do you agree? Let's take a 5-minute break. Come back here. Actually, let's take like a 7-8 minute break. All right. If you want to go outside and go to the bathroom, do whatever you got to do. We'll take a quick break. interesting. I'm trying to keep you guys as excited as possible. So let's just keep toughing it out and get some more work done. Are you guys cool with that? You ready to get back into it? It's been about 10 minutes, I think.
I was not expecting the first assignment to be coding.
I know.
Oh, well, yeah, it works out great. So yeah, we'll talk about that more later in lab. Okay, so all right. So what I'd like to do now, oh, there's a little focus issue there. Okay, so what I'd like to do now is go to page 8 and 9 in the workbook. And then Dom, do you have one to look at or no? You want a copy? I brought one. I think I gave you one, so I might. You got one back there, right? Yeah. Yeah, not yet. Well, it should be a good fire starter. All right. So now, where were we? 8 and 9. Okay, so this part, a lot of you probably already know how to do this. We're going to talk about unit conversions. What's the best way to do a unit conversion?
I don't know.
Stick it in Google. But is that going to work on test day for you? Nope. So it's not bad to actually learn some of this yourself, right? And I worked really hard and I was able to find a few really rare conversions that Google couldn't do. But you had to work pretty hard at it. It was a very, anyway, so I want to talk about unit conversions. And yes, this is another way where chemistry actually does a good job. All right. So we got to give them props when they get it. All right. So on pages 8 and 9, you can see just kind of a bunch of handy formulas for volume of a cylinder or surface area of a sphere versus its volume. And then at the top of page 9, you can see a bunch of different conversion factors, different units. Remember, what do you get on test day? Look at the back of the book. Take a look at the top of the book, the top of the equation sheet. You can see that there's a lot of these unit conversions are right there. So if you're wondering, what do I have to memorize for test day? Anything that's not on the back, okay? All right. So in this case, yes, go ahead.
Infer that we can use the workbook on the test?
No, I give you a fresh copy of this every day. So what's going to happen is on a test day, the front page is going to be the exam sheet. And I'll say, don't open your test until I say go. And then you have exactly the same amount of time as everybody else. And you just got to fly through it. You rip off that page and then got it? Yeah, you'll get a fresh copy of this. Yeah. All right. Good question. Others? All right. So I know you've seen some of this before. Look at page 9 and you can see examples 1 and 2. For now, I'm going to skip to problem 1.18 because I think you're supposed to know at least a little of this. But again, if you have trouble, let me know later. Let's try 1.18a. All right. And I have 2 accelerations, A1 and the second acceleration. Yep. Okay. How many sig figs are in this first one? Real quick. 2. Somebody else. How many sig figs are in this one? 3, right? These are trailing, but they're okay. You got it. All right. So now what are we going to do? Convert A1 to feet per hour squared. There are many correct ways to do this. If you think you know how to do it, get it done, check the answer and the solution. I'm going to do it one way on the board so people that want to can watch it. All right. Ignore me if you feel like you know how to do it, and check with the book. All right. Somebody mentioned the chemistry method earlier. I like that too. I call it the railroad tracks. I just make this big line here. And I know it looks stupid and maybe it feels too cheesy for you, but it works and it helps you pass this class and get a, you don't have to see me anymore. That's a good thing. All right. So, okay. I need to convert these millimeters. I'm going to look in my chart or on my equation sheet and grab something that has millimeters in there. Or maybe I just know from experience that there's 1,000 millimeters in 1 meter. Right? So then, and maybe, do I have something? Oh, actually, you know what I might do? I might do this. There's 10 millimeters in 1 centimeter. Because I have to get to feet, right? So I'm thinking, oh, how can I get to feet? I know the conversion between centimeters and inches. I know that 1 centimeter, whoops, sorry. 2.54 centimeters is exactly equal to 1 inch these days. Wasn't always the way it is, but been that way for some number of years now. They made that an exact conversion. All right, what else do we got to do? Yeah, 12 inch, 1 foot. Got it. So that's going to take care. And what I want you to look at here is I'm just trying to work on the numerator. The idea is this is the number 1. 1 centimeter is equal to 10 millimeters. That's like multiplying by 1. It doesn't change the number. Now, in this case, I see these millimeters are going to cancel out those. Centimeters going to cancel out those. Inch is going to cancel out there. I end up with feet in the numerator like I want. Now, what's the conversion for seconds to hours? Does anybody have that one?
3,600 seconds.
Yep, that's a quick one to know. So I know that 3,600 seconds is 1 hour. So am I all good? No. Oh, I'm a terrible person. What did I forget? The squared. This is the only, right? Okay, I'm going to stick one of these on your test. So it's easy points if you remember the squared, not, right? Because this right here is squared, I have to remember to square the conversion factors, both the numbers and the units. Sometimes people remember to square the unit and forget the number. Just please don't screw this up, right? So now at this point, I see that the seconds squared are going to cancel right there. But I still have to remember to square that 3,600. So at this point, grab your calculator, punch it in, make sure you get it. Okay. Hopefully most of this is reviewed today, but so times 3,600 squared, right? And then I have to divide by 10, divide by 2.54, divide by 12. Right? It looks like I'm still in engineering mode. Calculator. Remember, use those modes on your calculators. And it looks like, what notation did I say to write in? Scientific notation with correct sig figs. So first, let's write down the number, maybe with an extra sig fig, and we can worry about it later. What units are left after all this crap? What's left on top? Bottom? Hour squared. How many sig figs? Pay attention right now. I know you're tired. Here we go. How many sig figs in the original number? 2. How many sig figs in this? Infinite. Yeah. The standard is conversion factors have infinite sig figs unless otherwise specified. Am I wrong, Dom? Crazy, right? Look carefully at your equation sheet now. I've been hiding it till now. This is the fun reveal. Look at that. Look at that. Do you see how some of the unit conversions actually have a sig fig noted? In particular, 1609 meters in a mile is not exact. It does not have infinite sig figs. That one only has 4. But any of the others that you look at, if there's not a number of sig figs specified, assume they're infinite. In general, not always true, but almost always true. A unit conversion will almost never change the number of sig figs. Based on that reasoning, if there's 2 at the beginning, how many should I have at the end? 2. Don would be annoyed if you wrote that. So we would say, no, no, no. He doesn't want to see that underline. And I forgot a square down here, didn't I? Thank you. That's the conversion. Right? And the reason we do this, if everybody gets used to writing things the same way, it's faster to communicate later on when the work gets hard. We don't want to be wasting time on this stuff when we actually have to learn physics. All right. Jules, anything you want to say or anything, or are you good? Okay, anything, anybody else? Any questions? Yeah, go ahead.
So in this,
Which number?
in this first one, 1609 meters equals 1 mile.
Right?
So in that case, would you still use the force?
Then the conversion factor would have 4 sig figs. And since most engineering quantities have 3 sig figs or better, or well, usually 2 or 3, we wouldn't worry about that 1609 too much. Good. Yeah, so, and I will, on the test day, I'm probably not gonna make the conversion change it, because that would be cruel. All right. But just be aware that in some weird cases that could happen. All right. Yeah.
Would it be metric system?
What's that?
Wouldn't it be awesome?
Yeah. I mean, I don't know. Inches have their merits sometimes too, right? 12 is easily divisible by 3 or 4, so you can do thirds, halves, sixths. So there's pros and cons to different units, and I definitely prefer metric. I'll leave it at that. Yep. All right. All right. Any other questions on that? 1.18. Yeah, got one or
Fahrenheit or Celsius?
Rankine? That's just a nerd joke. Oh, Fahrenheit, right? It's got finer gradations, right? So there's pros and cons. They both, yeah, but so anyways, yeah. Just use kelvins. We're good. All right. All right. When does this class end? 1:15, right? All right. So, okay, good. I'm going to let you work on some of those problems on your own at home. I want to make sure we finish chapter 1 today. So let's take a look at page 11, problem number 1.26, and see if we can kind of put some of this together. I'm assuming you know what density is. If you don't, it's at the top of page 10. So let me get to a new board here. Whoops. 6. There we go. So let me get this metal rod out of the way. .26. So I'll start writing it up on the board. You can start reading and digesting on your own. This is kind of the first problem that's more like what the class will be like. Okay. You have a square nut made out of some metal here, and there's a hole in it. All right. We're told the diameter of the hole is capital D. Thickness in this dimension is T. Sorry, that's a little sloppy. The side length here, and the side length here, it's a square nut, so those are both S. All right. We're going to ignore the threads. Maybe it hasn't been threaded yet. So this is just a piece of metal. It's basically a square plate with a hole in it. If we can't handle this, how are we going to handle physics, right? So let's start with this, and I want you to tell me what is the volume of metal in terms of the letters, not in terms of any numbers. I want you to come up with an algebraic expression for how much metal is there. What's the volume of the metal in that nut? Does that question make sense? I'm going to stroll around. Try not to look at the solutions right away. Try to actually think about this. And Jules, if you can spin around, or if you want to, if Dom wants to spin around and get up if he's bored too, take a second to think about it. If you want to talk to your neighbor, go for it. Okay. You could get blank. You know how it is, like how you first try it, so.
Wait.
Feel like you have an idea? All right, I'll let you work. Okay. Remember, you got your equation sheet. Idea of how to start?
Yeah, still.
Okay. Remember, don't be shy. Talk as much as you want. You can vent to Dom how frustrating it is having me as an instructor if you have to. Whatever it takes. Anything to stay awake. Yeah. How's your day going? Yep. What do you think? Doing all right? Oh, okay, so if you finish early, remember, if you already get it, just do the rest of the problem. Do the rest of anything. Because we all at different stages, especially at the beginning. So that's why I gave you the solution. When you feel like you got the answer, just keep working and just do an infinite amount of physics. Just keep going all the way down the page if you want. Always be working. The harder you work in class, the less you work out of class. That's my philosophy. Oh, shoot. All right, my bad. Oh, Jose, I'm not sure. Jose Morales, did you get your question answered? Sorry about that. You can dump it in the chat again if it's easy. Oh, I'm sorry about that, man. Sorry about that. I think Jules got kicked off the Zoom, and so we had a screw up there, and our communication was bad. All right, right on. Sorry about that. Anybody else out there in Zoom land? You can throw it in the chat, or you can speak up, whatever you want. And remember, you got the solutions too, so. You get the whole page yet? So remember, so the trick is, right, it's gonna be, just keep working it here, and then, right, you'll have less to do outside. Because right, I can tell already you're like working pretty quickly, right? So try to just fly through it all, and then then you have less outside classwork, and then you'll have more time to take practice tests later, and so, yeah. Or you could have, Jules was also somebody that's always faster than selection. You could ask her side stuff, but she recommends for that class. And anyway, all right, yeah, just keep working. Have you seen this demo, Jules? Oh, it's kind of fun. We're gonna, yeah. Hold on. Yeah, right. Shorting out the terrible sound. Yeah.
Oh, I think it's frozen.
How about you?
That makes sense. Yeah, yes, that makes sense. That's just got to stay right here.
Oh, okay. I'm going to go ahead and start working it out on the board in case that helps the Zoomers. You could read the solution. You can watch me. You can do your own thing, whatever works best. You guys that are circling, keep circling. All right. So those of you on Zoom, the trick here, right? We've got length times width times height, side to side, thickness. The thickness in this case is the height. And then you got to remember that it's diameter over 2 squared, so the d gets squared and the 2 gets squared. Sometimes people forget that. Factoring out that t, I think you get this.
Oh.
All right. Just so we have it on the tape. All right. And then once you get that volume, go ahead and try plugging in all the numbers and keep track of the sig figs. This is an ugly one, right? Try to keep track of the sig figs as you go through it, and you have to deal with prefixes and unit conversions, all right? I know everybody's working right now, maybe just for one split second. I just want to make sure I address one thing to everybody. In chemistry class, a lot of times they use capital D for density. We're going to use the symbol rho. It's a Greek letter. If you don't know how to draw it, it starts here and goes up and back down. Rho, 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 your density. So Greek letter R for density, just so you know. Okay, back to work. Back to work.
Jorstad?
Answer this. We have this 126.
The Jorstad? Your goal with this problem is to figure out the mass of the nut with correct sig figs at the very end. And I wrote the answer here, so it'll be in the live stream if you need to check it later. I'm going to start circling as well, just making sure that people on YouTube knew where we were going, all right? Okay, so that's what we're trying to do, is we're trying to show that and do all the work. It's nasty. All right. How are you? Okay. Okay, that's good practice, but I would say this. Look, you know the volume of the metal, and I want you to get to the mass. What's going to help us convert from volume to mass? Density. So what I would do is first use your density equation to convert your volume equation to a mass equation, which is letters. We want to wait as long as possible before plugging numbers because it's going to be a nightmare, right? What's another good strategy? What do you notice about all these units here and all the numbers up there? Right here. What do you notice about all these crazy? They're all mixed, right? Before you start plugging anything in, convert them so they're all just in meters and kilograms or something, right? We know we want to get kilograms in there. Why not get all these stupid units converted to the same thing, meters and kilograms, and then you won't screw up. And that's the trick that we're trying to learn. Is that good? Yeah. Should I let you roll? Right. All right. Oh, okay. remember, if you get stuck while I'm circling around, you can check the solutions for him, right? And there's nothing wrong, right? And there's gonna be plenty of practice tests later. Use those solutions. Right? What do you think? You doing all right? Yeah. Okay. I will. Be careful. Did you see the mixed units? You plug these in, look, meters, inches, that's gonna be terrible. Take a look. What I would do, I've got it right here, right? If you just start plugging in these numbers, you're gonna have inches on one, and that's like adding apples to oranges. You forgot to, I would get everything into, like you could get everything to centimeters if you wanted, or everything to meters if you wanted. But right, you've also got grams here, and so do something with the units so that they're all in a normal unit before you start messing around. And I know this problem probably looks a little bit crazy, but if you start like trying to back engineer things off the internet, this happens all the time where one website will be in inches, another one, and so you're constantly having to do this in the real world. It's a real life skill that's somewhat useful. What do you think, John, Dave? Yeah. Does it make some sense? Did you get it? Same face, did you get the same face too? Yeah, that's the trick, is keeping your sig figs. You gotta be like, oh crap, we gotta hunt. So I know there's other lines, but when you're doing something wrong like this, you know, like, definitely like those. Yes.
When you sig figs, that's fine.
Is it infinite? Oh, yeah. Oh, yeah, pi is infinite, yeah. Oh, yeah, that's a good point. Don, I see what you said. I know where it's going. If you ever see these formulas like this, we should probably address this right now. This is a good one. So everybody listen up, just in case. This pi came from a pure math formula, right? The ratio of a circumference to the diameter, right? And here, this 2, right? You might be saying, well, what about this 2? Well, I'm assuming that if I take a diameter and perfectly divide it in 2, so this 2 would also have infinite sig figs. Or maybe you're thinking about the 1/2 in x equals 1/2 at squared plus v initial t, or something like this. A lot of these numbers in your formulas will have infinite sig figs, just like the conversion factors have sig figs. If it comes from a mathematical formula like this, that would have an infinite number of sig figs. So this term right here will not affect the sig figs of the math. Good? How are people feeling on this problem? Thumbs up, thumbs down? Are you making progress or not? Just checking. What do you guys think? Yes, no? Sideways is fine too. Do we want to spend a couple more minutes on this before we do a demo, or what? Okay, let's do a couple more minutes, and then maybe the last 10 minutes of class, we'll do a couple of demos, all right? All right. There, let's go over this side here. Let's go back. All right. Okay. Remember that everybody should know this. It's okay to follow along with the solutions on the first problem if you're getting lost. You feel like, man, I have no clue. What will happen is later, the week before the test, I'll give you practice tests. And then, so if you're using the solutions a lot at the beginning, that's good. And then you want to wean yourself off of them. You don't want to be doing the homework with the solutions all the time, but now is definitely the time if you need it. Okay, so far so good though? Yeah. Okay, fine. How about here? Okay, all right. Should I just let you work that, or? Oh, we're looking for the mass. Yeah, let's just look for the mass. Cool. Yeah, okay.
Any practice with somebody.
Okay, yeah. Okay. That's why we're doing this, right? So, right. All right, how about you? Sounds good. How about that? Yes, absolutely. See, you're going to be done, right? Yes, exactly. And so I didn't just say P equals this, did I? So sometimes you see it, that's one of the annoying fun parts about this. Right? Okay. How about you? You do all right? Yeah. All right, we'll go away. All right, right here. Okay, guys. The progress? All right, good. How about you? Making progress as well now? Yeah. Yeah, there you go. That's it. Okay. Oh, yeah, you got it. Sweet. So then if you want one,
So what is?
somewhere? Yeah. You know, a trick that I do is when I have the PDF, I'll just take Control F. Usually goes right there. Yeah.
Which way?
Yeah, now, if one of the answers has 1.26 in it, you might have to hit a couple, but yeah. So when you're using the solutions, remember, you could just hit Control F and type in the problem number and you're right there, right? So if you're, yeah, all right. I haven't checked in the front here. What do you think? You get somewhere?
Yeah, I had to start all over, so I forgot.
Hey, now you won't make that mistake on test day, right? That's why we're doing this now. So we're good. All right.
I do have a question. When I was converting this 50.3 millimeters to centimeters, I just moved the decimal.
Yeah, that's fine. Yeah, I mean, if you screw it up, you screw it up, right? So, but yeah, do you agree that should, yeah, you don't need to show work for that. I agree. All right. Oh, got a question? Don, you want to get it or you want me? Sweet. How you doing? Does that make sense? Where, which line are you at?
You know, last.
Okay, follow through the same page.
Yeah, because they only convert to the
Yeah, that's right. Oh, yeah, so I saw for it grants. You're right. All right. Good.
Yeah, thank you.
All right, that's good. You guys get there? You want a regular calculator for the day? Just make sure I get it back. You're so much better than that. Yeah. Yeah, you could change that to millimeters, sure. 4.5 millimeters or 45 centimeters, right? So you could, that's the thing, you could convert it to centimeters, you could convert it to. You gotta pick something and do it, right? Yeah.
But it would be right there, it don't be millimeters.
Yeah. What's our goal with this problem? What are you trying to do?
Find the math.
Mass. So what's gonna drop out? Everything except kilograms.
Yeah.
So it doesn't matter whether you go to meters or centimeters, you get to some freaking units. And they're all the same, and then let it all cancel out,
I'm
right?
just trying to get to centimeters, it's centimeters.
Sure, right, that's what I thought, I'm like, I don't wanna have this, right? What's the conversion most likely to screw up? The density. So don't change that one, change all the others.
Yeah.
Perfect, right, yeah, that's exactly what I would do too. Okay, any Zoom questions there? Just checking in with you Zoomers. You guys are troopers today. It'll get better. Okay. Who was I? Who was I next? Somewhere? Let's see, density is mass over volume.
Density.
So
Grams per centimeter.
like one of the things that I most commonly struggle is putting it upside down.
Density is grams per centimeter.
So you're right, mass would then be density times volume, yes, you're right. You have to write this right here. What's that? Yeah, exactly. This was our volume. And then if you know density equals mass over volume, that tells us mass equals density times volume. Yep. Yeah. Good.
Oh, no, you're good.
Okay.
Yes, sir.
All right. So, Dom, are you at a good spot or not?
I don't know.
Okay. So I'm looking at the time, everybody. We've got 10 minutes left. I thought I might as well show you something slightly interesting as a reward for all this pain. And so let me see if I can get this kind of on the Zoom setup here. What is this for? Let me see if I can do this right. All right. It's not perfect. All right. So I have here a little kitty aquarium. All right. And if you guys want to stand up in a minute, you can do this one. Go ahead. So I have some moss spores. This is lycopodium powder. So what I'm going to do is I'm just going to sprinkle some of this on here. And again, you can stand up, you can walk around the room, you can take a break, whatever you got to do. You can run away screaming, it's never come back, whatever's easy. All right. All right. So now in this case, I just put these moss spores on the top. And now what I'm going to do is I'm going to do problem 1.30. If you want to read about it later, what I'm going to do is I'm going to get a small micro pipette of oil. I'm going to get the smallest amount of oil I can, which is supposed to be half of a microliter. And an interesting thing happens. Just a sec. This one's the one that goes down there. Yep, I stole this from biology, cranked it down to the minimum they loaned it to me. So if I have bad pipetting skills, this is the only thing I ever use it for. So I apologize if you're a biologist and you're offended. All right, so there's a tiny drop in here. Now, not all this oil is even going to go in here, just a tiny fraction of it. Can you verify there's a drop of oil there?
There's a drop of oil.
Very tiny oil, all right? And then I need a meter stick. Oh, that one's attached to a board, I think. You got it? Oh, you got a measuring tape? I'm just gonna grab a meter stick just because I don't have the thing. Everybody, that's Angus. Let's give him a round of applause. Angus does all the real work. He makes sure the demos work for me. All right, so I've got this on meter. So what's interesting, I mean, it's hard to make sig figs interesting. This is it. Let's just do it. Ready? So what's going to happen is the oil, when I put it in here, will spread out to a single molecule thick layer, a monolayer. And from this, you can actually get the size of an oil molecule. There it goes. So what you could do is, right now the oil is spreading out until it's approximately 1 molecule thick. And then what is that? About, just eyeball it. How many centimeters across? Maybe 40? 40, yeah, so somewhere in there. So what we could do is we could say, okay, for this oil, I got a half a microliter, and I know this distance is about 40 centimeters. In theory, you could use that to calculate the thickness of an oil molecule. As a weird old story, Benjamin Franklin used to go around with a hiking stick, and he'd have a little vial of oil, and he would just create oil spills on lakes with one drop and watch it spread out across. Strange things to do. That's all I got. That's it. All right, so if you want, go back to your seat for a second. That is, take a look at problem 1.30. Have you seen that one, Dom?
That was exciting.
I know, right? It's sig figs. I'm trying, people. It's hard to come up with demos for sig figs, but that's what I could come up with. So I think you know, it's that micropipetter is at its smallest increment size. And let me get this back up here. Gosh, it showed up not at all on Zoom. Sorry about that, people. All right, so if you're looking at question 1.30, you can see that you have this spherical drop that turns into a giant pancake, and from that you could try and do the math. So if you're interested after class, you could do the math on that. Now, the other thing that has almost nothing to do with anything here, let's just do this over here. And then we'll get you out of here. Come on. Let's do this. So there's another thing that lycopodium powder is famous for, this moss spore. Does anybody know what it is? All right, let me make sure get anything flammable out of the way. All right, hopefully this shows up, but I don't know. Now, I am going to breathe through this tube. So I haven't thought this through. I have to take off my mask to breathe in there. If that offends you and you want to leave, that's cool. But if you keep all your masks on, I'm going to have one breath through this tube. I think we'll be all right. So I want to do like probably be all right. I'll try not to burn you. All right. Get this one off of here. So if you're worried about something burning, maybe get it out of the way. It should be about this big. All right, so lycopodium powder is extremely flammable if you get it aerated. I'm just going to put some moss spores here. I got this little blowtorch somewhere. And then it turns out when it's sitting in a big pile like this, it won't burn at all. So the trick is get this close to the flame, but not blow it out. And this has nothing to do with sig figs. It's just fun. Since I got the lycopodium powder out, I'm doing it. Let's get some lights for effect. All right, Zoom, I hope this shows up. Where are we here? Oh. Come on. Let me see if I can get this in there. Oops. I think that's pretty close. Oops. What's that?
I'm just saying, if I'm gonna get it burned, might as well make it worth it. I'm gonna try to.
Yeah, you got to have this recorded, right? That way you can see the school.
It'll be on YouTube, don't worry.
That's right. That's right. On the least watched channel in the universe. Okay. All right. You ready? Let's just see if I can do this without burning my face off. The trick when you're doing this is inhale before you put your mouth on the tube so that you don't suck in a huge pile of moss, which I've done. Oh. Yes, I can blow out a flame. I gotta get this layered better. Let me get this angled down at it. All right, one more try. Ready? That's kind of cool, right? There we go. That's it. Class is over. All right, fireball. Yeah, it's crazy. That's how grain explosions work too. When the grain gets up in the air, it can light on fire and it's very explosive. All right.
If you have questions, send me an email. I've got office hours. You can talk to Dom, you can talk to Julie. Dom, should I add you as an instructor on this course if you want or not? Yes? Okay, I'll do that later today. All right, let me get the lights for you. If you could, if I gave you a laptop, could you help me try to put it back in the correct spot and plug it in? If you have trouble with that, I'll take care of this.
I'll put them here.
Oh, yeah, calculator. Thank you. Appreciate it.
You're welcome. Both of them are there.
Right on. Kind of fun to have fire in class, right? Something to do. There we go.
It does smell kind of like.
What's that?
It does kind of smell like.
Yeah, yeah. Well, sometimes what happens is I burn my eyebrows and hair and stuff, so it might be some of that, or I don't know. I just burnt, yeah. Anyways, it's cool, right? Something to do.
Wait, what was it that you put?